The Larsen C ice shelf in Antarctica, from which a Delaware-size iceberg broke away 2 years ago, could be at risk of collapse. Scientists recorded a spike in late-season surface melt of snow and ice, which they said was being driven by warm, dry winds coming from mountains in the Antarctic peninsula. Larsen C is a vast body of ice sitting at the edge of West Antarctica, covering an area of about 17,100 square miles. While its physical breakup would not cause sea levels to rise directly, Larsen C could be a harbinger of things to come for ice shelves farther south. Should these larger bodies of ice follow the same path, it could result in sea levels rising by several meters. In 2017, Larsen C made international headlines after researchers monitoring it said a huge iceberg was about to break away. They warned that this event would leave the ice shelf less stable and at risk of following the same fate as Larsen A and B, the latter of which disintegrated in 2002 after a large iceberg broke away. In a study published in the journal Geophysical Research Letters, Data, from the University of Maryland, and colleagues used data from the last 35 years, including information from weather stations and satellite observations. From this, they were able to work out patterns in the surface melt of ice and snow at Larsen C. They discovered that between 2015 and 2017, there was a spike in melting as a result of warm, dry winds blowing across the ice at the end of the summer melt season. More surface melting is bad because it causes water to enter the layers of uncompacted snow beneath. This snow makes up the upper layer of the ice shelf. When the water trickles down, it then refreezes and causes the layer to become denser. Eventually, this layer becomes so dense water cannot enter, and instead starts to build up at the surface. It is thought that this process may have been involved in the fracture of the Larsen A and B ice shelves. Blue pools of meltwater can be seen collecting atop the Larsen C ice shelf. NASA Earth Observatory/Loren Dolphin. While 3 years cannot constitute a trend, should it continue it could have major ramifications for the stability of Larsen C, the team concluded. In an interview with Newsweek, Data explained, "One of the main ways that we monitor the health of the Larsen C ice shelf at the surface is to quantify where the density or ice content of the Larsen C is starting to approach that of the Larsen A and Larsen B ice shelves." The northern portion of the Larsen C has already reached the density levels that preceded the breakup of the Larsen A and Larsen B ice shelves. This is important because one dominant theory of how the Larsen A and Larsen B ice shelves collapsed was that an increasingly dense snowpack was able to support melt ponds. These melt ponds then wedged open pre-existent crevasses, which lead to a catastrophic collapse of the ice shelf. She said it is not clear if the warm winds contributed to the major calving event in 2017, but that the iceberg broke away toward the east of the ice sheet, while the winds mainly affected the west. Most experts on the subject have suggested that this calving event is actually a product of normal processes, she added. Next, Data said he planned to investigate what happens to the meltwater produced by atmospheric drivers, including the warm winds. "I've shifted my focus to observational work on how meltwater evolves on the Larsen C as well as other ice shelves and some glaciers," she said. As for the fate of Larsen C, Data said long-term climate models suggest that it will disappear eventually. Exactly when this happens is not known, however. The biggest concern about the breakup of the Larsen C would be the glaciers that feed into it. While the disintegration of the floating ice shelf would not directly contribute to sea level rise, the ice shelf also supports glaciers on land behind it. With the loss of the ice shelf, some of these glaciers are likely to speed up and contribute directly to sea level rise.